Hello, this is Scholar Strife doing some math today in geometry. We'll be working with circles again. This time we'll be looking at finding arc measures. So first off, let's go through some vocabulary. A central angle is an angle whose vertex is at the center of the circle. So this angle here, that red angle there. A minor arc is a part of a circle measuring less than 180 degrees. So, for example, let's call this A and C again. AC with an arc above it is called, well, arc AC is a minor arc because it is less than 180 degrees. A major arc is something bigger than 180 degrees. So it's an arc that's bigger than 180 degrees but less than 360. So let's draw a circle. Now let's say I want to measure BD, but going this way. Now normally when you're measuring these, they will usually give you a third point to tell you the direction that you're going in. So this would be arc BCD, and this would be a major arc, because this angle here following the red line would be bigger than 180 degrees. And let's just say it's that arc BCD is 190 degrees. That would be bigger than 180, but less than 360. Okay, if they still only give you 2 points, then they'll either ask you what is the major arc of AC. So if we're looking at this one where I'm drawing that, or they'll ask you for the length or the measure of the minor arc, which would be the blue here. So in this example, the minor arc AC is 80 degrees. The major arc AC is equal to 360 minus 80. Because a full circle is 360 degrees. If the blue piece is 80 degrees, then the red piece will be 360 minus 80, which is 280. A semicircle is an arc that's exactly half a circle. It measures 180 degrees. Congruent circles let's call this circle B and circle C. Let's say I drew them the right side. We would say that circle B is congruent to circle C if they have the same radius. Now let's just pretend I drew the same circle twice. Congruent arcs are two arcs that have the same arc measure. And then the arc addition postulate says we can take two arcs and add them together. So arc AB plus arc BC is equal to arc ABC. Alright, the measure of a minor arc is the measure of its central angle. The expression AB is read as the measure of arc AB. The measure of the entire circle is 360 degrees. The measure of a major arc is the difference between 360 and the measure of its related minor arc. The measure of a semicircle is 180 degrees. And we have this little example here. So they tell us that the minor arc is 50 degrees. That would also tell us the central angle is also 50 degrees. To find the other part of the circle, so once again the minor arc is in blue and that's 50 degrees. To find the red, which would be arc ADB, going in that direction, we would do 360 minus our blue to get the 310 that they have there. Alright, let's do some examples. Find the measure of each arc of circle C. So DE, so let's use colors. So we're looking the arc from D to E, okay? So they tell us that this angle here is 117 degrees. So that's easy, 117 degrees. Central angle tells us that that's 117 degrees. Okay, DFE. Yeah, let's change the colors a little bit. Okay, and then DFE. Okay, that's going to be 360 minus 117 degrees. Because a full circle is 360, that blue piece is 117, so we just subtract it from 360 to find the red piece, which is 243 degrees. DEF, okay, let's do different color. DEF is right there. Okay. We know that that's half the circle. So therefore, 180 degrees. Okay, checkpoint 1. Find the measures of all arcs of circle P. Okay, let's start off with RS. Arc RS. So you just put RS with an arc above it. That's equal to the central angle, 45 degrees. RTS, going backwards, RTS with the arc is 360 minus 45, which is 315. Okay, and then the last one, green one, which is TR. Oops. We know that's 180. So, but the green is 180 minus our blue 45. Because, let's use a different color. This brown or orangish. So this brown thing here is 180 degrees because that's half a circle. So the green is the orange plus the blue part. Or the green is orange minus the blue part. So that's where I get the 180 minus 45 from, which would equal 135. Okay, example 2. You open accounts at a bank and divide your money as shown in the circle graph. Find the measure of each arc. Okay. Measure of angle or arc BD. Okay, you always want, if they tell you just 2 letters, they always want you to pick the quickest route, unless they say major. Then you take the longest route. Minor would be less than 180, major would be bigger than 180. Okay, so BD is 55 plus 105, checking and savings. And that would be 160. Now, this would tell us how much of where most of our money is going, because there's checking, there's savings, money market, and bonds. Checking and savings is 160 out of the 360. Okay, that would tell us, and then if we had a total amount of money, we would be able to figure out how much money is going to each of those. But they just wanted us to find the measure of each arc. So BCD, okay, B to C to D. Okay, that would be 140 plus 60, which is 200. Tell whether the given arcs are congruent. Explain why or why not. Okay. So they want BC, which is 75, and DE, which is 75. Yes. Both 75 degrees. The arc measures are both 75 degrees. AB and CD in the next one. Oh. So AB. Okay, that's the red arc here. And CD is right there. The central angle is 80 degrees. The red angle, or the red arc measure, is 80 degrees. And the blue one is also 80 degrees. Now, we're not talking about arc length, we're talking about arc measure. Arc measure deals with degrees. Arc length deals with the actual distance. So in this case, the arcs are congruent. But let's be sure and check our vocabulary. Two arcs are congruent if they have the same arc measure and are in the same circle or in congruent circles. Ah, okay. So this one's actually a no. Because to both be congruent arcs, they have to be in either the same circle or be in congruent circles. Circle A and circle B are not the same circle. They're actually the inner circle and the outer circle are two different circles. So no, CD, arc CD is longer than arc AB. So that's why vocabulary is important. There's arc. To have congruent arcs, they have to have not only the same measure, but same length as well. Alright, FG and HJ. Yep. Yes. Same measures. Same measures in circles that are congruent. Checkpoint 2. In the diagram, PQ is congruent to SR. So we're looking at two arcs again. PQ and SR. Are these congruent? Yes. Because of this little marking here tells us that angle is the same as that angle. So the arcs have the same measure. And they are in the same circle. And that's all I have for today. Have a good day.